Hello.
Hello, may I audible?
Hello, sir. I am audible to you.
It's breaking. May, may I audible? Hello,
Yes, sir.
the voice is clear or not?
Yeah, there are some network issues, sir.
From my side or your side?
That's why, sir. Am I audible, sir?
You are audible, but
Yes, sir.
your
Yes.
voice is breaking. Just I
Hello.
want to confirm from my side, is it
Yes,
clear
sir.
to
Your
you
voice
or
is
not?
clear, sir. Yeah, I think my side, sir. My side, I have problems.
Okay, Sahil?
Yeah, yeah. Yes, sir. Yes, you are clear, sir.
Okay, 4 o'clock we have to start, right?
Hello, sir. Good afternoon, all of you.
Sorry,
No, sir. In 3:30, sir. We have
3:30
3:30
itself.
time.
So give me 5 minutes, I will start, right?
Actually, we have 3:30 time, sir. Three.
See,
Yes, sir.
there are only 9 participants as of now.
Yeah, okay, sir. As you
So
are convinced,
so after 5 minutes
you
we will start. Is it
can.
okay?
Hello, am I audible, sir?
Yes, you are audible.
Yeah. Good afternoon to all, and welcome back to our online training sessions. Behalf of the Department of Agriculture Economics, MPKV Rahuri, I welcome our today's expert, Dr. Yogesh Ashok Gabde sir, who is Assistant Professor, Department of Agriculture Statistics and Computer Center, Navsari Agriculture University, Navsari. Sir has graduated from Dr. University of Agriculture Sciences and Technology, Pantnagar, and sir has completed his PhD from BHU, Varanasi. Sir has more than 10-year experience in research, teaching, and extension. Sir has major interest in crop yield forecasting, time series analysis, and application of RS and GIS in the field of agriculture. Sir also authored 2 books and published more than 20 research papers in Journal of National and International Reputation. Sir also has recipient of various awards, including Young Scientist Award for outstanding contribution in the field of agriculture statistics on the occasion of International Wealth Conference and on innovation and current advance in agriculture and allied sector in 2021. We are pleased that such a great and intellectual personality with us today. I would like to request, sir, please share your knowledge with us in this session. Thank you, sir.
Thank you very much. Very nice to introduce me to all of you. Uh, may I audible to all of you? Please, you can make
Yes,
the.
yes, sir. Yes, sir. You are audible. Yes, sir.
Okay. Is it my presentation is visible to all of you?
Yes, sir. It is visible.
Okay. So, topic which is assigned to me, that is about basic statistic, and in which we have to cover the measures of center
Yes, sir.
tendency and
Yes,
dispersion.
sir. You
Sorry. Hello.
and you can share screen, sir. You are co-host now.
Is it visible?
Yes,
Yes,
sir.
sir.
And it's moving?
Yes, yes, yes. It is
Okay.
working.
So today's is we are talking about the very basics about the statistics, which are required to be understand while go for the very advanced things about the statistics. So let us we start with introduction, and then we talking about the frequency distribution, measures of center tendency, measures of dispersion, and a little about the test of significance. So we start with the introduction. That's meaning of statistics. Generally, we see in our day-to-day life, we are dealing with the numbers. And when you are talking about the numbers, it's generally called statistics. If you're talking about the mass obtained in your particular subjects, it is about the statistic. You are talking about the how much you are getting highest marks in particular subject, or you are getting the lowest marks in particular subject. It's called statistic. So basically we are talking about the statistic. It's sense in two sense, that is plural sense and singular sense. And when we are talking about the plural sense, it means we are collecting the data set which is having the multiplicity of the causes, and it is have the numerical data, and this can be we can interpret it. It is about the numerical information about the all the facts. But when you are talking about the singular, it means it is a connected process, that like collection of the data set, then arrangement, then classification, then interpretation, and all this process, it is known as statistic, and it is called statistic. Basically, when we are defining the statistic, it is a branch of applied mathematics and which concern with observational data. So there are different definition which is given by the different scientists. So first of all, R.A. Fisher. The question may arise in the your examination, that is who is the father of statistics. So R.A. Fisher, you can say, is the father of statistics. So he gave the definition of the statistic like it is a study of population variation, and it's a method of reduction of the data. Similarly, the Al Bole is another scientist in statistics which give the definition of statistics. It's called the science of calculation and averages. Another scientist, Boddington, he defined the statistic as a science of estimate and probability. So whenever in general we are talking about the statistic, it means it is a science or it is a arts of collection, then organization, presentation, and analyze. And once you analyze it, then interpretation of your all the data set, it's called statistic. So in concern about the statistic, there are different terms also introduced, that is biometric. When you are talking about the statistic principle of statistic, when we applied on the living thing or organism, then such statistic is called biometric. Then another term, that is statistical methods. When you are talking about the statistical data and which analyze through the different tools, then it's called different methods which applied on the your data set. It's called statistical methods. Another two terms exist in the statistics, that is attribute and variable. When you are talking about the qualitative data, like color of the flower, shape of the seeds, or the length of the leaves, the structure of the leaves, all things we're talking about the quality, and then it's called attribute. But when you are talking about the variable, it means the value of the particular observation which changes to observation, person to person, or object to object, then it is called variable. Let us consider the example of the yield of the wheat. per hectare by the particular farmers, then it's called a variable. When you are talking about the variable, then there are two parts or two kinds of variable, that is qualitative variable and quantitative variable. And when we're talking about the qualitative, it means we consider the quality of the particular item or particular object. And when we're talking about the quantitative, we measure in terms of the magnitude. It means we measure in numerical form, that is yield of the crop or height of the plant or height of weight of the person. So things, such kind of the data which deals with the quantitative. When you are talking about the quantitative, there are again two types of the parts which consider under quantitative, that is discrete uh, data and continuous variable. Discrete variable and continuous variable. When you're talking about the discrete variable, it means it takes the definite number between the two values. It's called discrete. It means the number of students present in the class. There are definite number. Let us consider there are 75 students are in your class. Then it is called discrete data. We cannot call there are the 75.5 number of the student, because it cannot be divided. It cannot be fraction. So such kind of the data which called discrete variable or discrete data. When we are talking about the continuous, it means it take care of the fractional data set like height, weight. So we can count it the 70.49, 173.23. So whatever the fractional data we are dealing with, it's called the continuous data set. So there are different methods of the data collection, that is measurement, then scale, score, personal contact, and questionnaire. Those are the methods which are generally considered for the data collection. When you are talking about the measurement, it means we measure the particular length, height, then area, volume of the particular thing or a particular object. Then it's called measurement scale, measurement of the data collection. Scale, it means when you are talking about the temperature, humidity, they are talking about the in physical science, we are generally using this scale. When you make some qualitative data, we can identify or we have to convert in based on their rankings. So score or rank another types of the method of the data collection. Then personal contact, this is another method. Then questionnaires. In most of the extension work or social science studies, we are make the questionnaires to collect the data sets. So those are the methods we are generally using in the statistic. But the statistic have some limitation. When you are talking about the statistic, there are some limitation, like the first limitation, that is it does not deals with the individual. It means, let us consider when we are talking about the only one variable or only one object, we cannot make the comparison taking the only one observation. So whenever we are talking about the statistic, it should be two or more than two number of the individuals or number of the observations should be taken under consideration while using the statistic. Individual data, it cannot be processed, it cannot be interpreted through the statistic. Then another limitation of statistic, that is statistic deals only the quantitative characters. Qualitative, only quantitative character. It means it does not deals with qualitative characters, because whenever you're talking about the qualitative, that is performance or color of the flowers, shape of the seeds, we cannot make it. But whenever we are dealing with these qualitative characters, we have to convert it to into the quantitative, and then we can proceed it. So this is one of the limitation of the statistics. Another thing, statistic results always based on the averages. It means whenever you take the average of the whole your data set, the based on these averages or mean value, we can make our interpretation. And this is another one of the limitation of the statistic, whereas whenever we are talking about the dispersion, we talk about it. Again, the statistic can be misused, means whenever the knowledge of the statistic is insufficient and their concept, if it is not clearly understand, then whatever the interpretation or whatever the results or whatever the their suggestion given by the any person based on the statistic, it may be mislead to the users. Another thing about the statistic, that is it does not reveal the entire story. It means the statistic gives only the approximate value, only the estimated value. They does not give the exact value, and that's why the statistic, it is limitation about the showing the exact your data set or exact your interpretation. So those are the limitation of the statistic we have to understand while we are using these things. Now we have to talking about the frequency distribution. So before proceed to the measures of send and receive, we must understand what kind of the data we have and how they are distributed over this one. So while talking about this one, so while considering the data set, there are two kind of the data, that is primary data and secondary data. When we are collect our data set from the primary source of information, then it's called primary. And when you are taking the data set from secondary source of information, then it's called secondary data set. Secondary data set, it means when you are collecting the data sets from the magazine, reports, or any website, those are already collected. Just we are taking those data set. It's called a secondary. But primary data set, it collected by contacting our persons individually, face to face, and we have to collect the all data set. It's called the primary data set. Once you collect all the data set, there are different types of the data, or we can classify this data set in different their based on the different categories, that is geographical classification, chronological classification, qualitative and quantitative classification. When we are talking about the geographical classification, it means the classification of the data, it is based on the area, like a district, taluka, or state. So let us give here is an example about the cotton crop. We are talking about the area, production, and yield of the different places of the district, that is Ahmedabad, Banaskantha, Vadodara, Bharuch. Those are the places over the our data set is distributed. So such kind of classification called geographical classification. And when you are talking about the chronological classification, it means when you collect a data set throughout the based on the different time interval, like year, week, days. So such kind of data set, it is called chronological classification. Such kind of the data generally used in time series analysis. Let us consider the same area wise our cotton yield throughout the years from 1961 to 65. So those are data set are arranged throughout the chronological order of the year. So such classification is called chronological classification. Then qualitative classification. This qualitative classification, it is based on some kind of the attribute, that is the quality or qualitative data set we have to deal with this. And such classification, it is called qualitative. It is further divided into one-way classification, two-way classification, three-way, and manifold classification. When you are talking about the one-way classification, it considering only one parameter or only one attribute while the classification, like the gender of the our data set. The population data set is given. We are making their classes in male and female. That is only one attribute. But when we are talking about the two-way classification, where again included the another attribute, that is education. Whatever we are going to be survey or going to be collect the data set which is about the population, we have to first make the classify into gender, male and female. Again we have to make the sub classification, that is education, literate, and influence. When you proceed for the three-way classification, we introduce another attribute, that is marital status, about the married and unmarried. And when you are next further proceed for the again classification of your data, that is called manifold. So each section, it is again subdivided into again next level, that is education, literate, illiterate. In literate, again there are two section, male and female, and again this male, married and unmarried. Such kind of the data we have to generate it. Again we proceed for the different location, that is Maharashtra, Gujarat, UP, and so on. So such different kind of or different classification which combine in a one stage, it is called a manifold classification. When we are talking about the quantitative classification, there are we have to consider some magnitude of the numbers or magnitude form of the all our data set. Let us consider that there are different cows or different milk animals were classified according to their milk yield. Then this classification, we can call it quantitative classification. Again, there are two types, that is discrete classification and continuous classification. We're talking about the discrete, it means it takes the specific value between the range of the classes, that is number of petal, number of insect, that is complete number you are getting. That's why it's called discrete quantitative classification. But when we are talking about the continuous, it take care of the fractional data set. It taking the any value between the range of the your points or range of the any variation to be considered. While talking about the quantitative continuous classification, it taking the length, width, height of the any object, it taking the fractional data set. So it is called quantitative continuous data set. So before once you classify all the data set, then the next term is frequency distribution. The frequency distribution, that means the number of times the particular value, how many times it is repeated, it's called frequency. So we have to make such classification based on the data available with us. Let us consider here that there are mass obtained in the statistic of the 50 students is given. So this data set we have to make arrange based on the frequency distribution. We have to make the tally mass using the table. Let us see in the data set, whatever is given, we have to first of all find out the lowest value of your data set and maximum value of your data set. Let us consider here the lowest value is 44 and maximum value is 71. So on 44, 46, 47, and so on, we have to make the arrangement of all the data set, which numbers available with us. So we start with the 44, the number of 44, which is repeated, how many times we make the mass, that is vertical line 1 2 3, and once it is completed 4, and next line we have to make the cross. So such kind of the data set we are already studied in our 12th classes, graduation also. So such frequency for the particular class, we make the this tabular form. It is called a frequency distribution. It means how many times the particular numbers is repeated throughout the particular class. So there are again two types of the frequency distribution, that is discrete or it's called ungrouped frequency distribution, and another is continuous or group continuous frequency distribution. When you are talking about the discrete frequency distribution, it means it takes the value which is specific value, or it is particular value which is available in your data set. Let us consider there are the data set about the 40 families where the number of children available in the particular family or particular home, their data set is given. So we make the frequency tally mark with help of the number of kids, that is 0 to 6. So accordingly, making the tally mark, we are seen there are number of children, how many times it is repeated in the our data set. It's called a discrete frequency distribution, and it take care about the specific number or unfractional number. But when you are talking about the continuous frequency distribution, we can make such discrete frequency distribution into continuous frequency distribution. While making the classes, we have to take care about the 0 to 2. We make the class about the this one, then our data set, then 3 to 5, 6 to 8. So within this range, how many numbers of the kids are available or children are available, we make the frequency table. So when you are talking about the continuous frequency distribution, it take care about all your numbers which is available in particular class. When we are talking the continuous frequency distribution, it take care about the then fractional data also. So while doing this, we have to make the classification, that is 0 to 20. This is another example, that is of mass obtained out of 100 in statistic of the 100 students. So the mass, it can be 20.5 or 20, 40.3 or 60.7. It means it take the fractional number also. So while doing this classification, continuous frequency distribution, we have to make the classes like 0 to 20, 20 to 40. So whatever the fraction data, it take care about this upper or lower limit of the class. So while talking about this, we have to first understand what the terminology is generally used while the frequency distribution. So we have seen about the example here, that is this one. The class is 0 to 20 or the class is 20 to 40. So when talking about the class limit, let us consider in the previous exam the 10 to 20. This is our class. When you are talking about the 10 number, it's called lower class limit, and the 20 is called upper class limit. Okay. So whenever we proceed further, that is class interval. That is another term which is generally used in frequency distribution. The class interval, which talking about the difference between the upper limit and your lower limit. Let us consider your class is 10 to 20. So then class width or class interval, it becomes 20 minus 10, that is 10. 10, it is your class width, or that is your class interval. Now range. The range, that talking about whatever the value, highest value you are present in your data set, or whatever the lowest value present in your data set, the difference between this highest value and lowest value, it is called the range. So in the particular data set, in the example, we've seen your highest value is 6 and the lowest value is 0. So difference between these, it indicates the range of your class. Now, next term, which is called mid value. Let us consider the class is 10 to 20. Your class is 10 to 20, then mid value, it is calculated based on your upper class limit and lower class limit divided by 2. That is, you have to make the average of these two values, 10 plus 20 divided by 2. So we'll get the 15. 15, it is your mid value of your class. When you are talking about the frequency, it means how many times a particular number is repeated in particular class, then it is called frequency. Now see how many number of classes we have to count while doing the classification. It can be made using this formula that is given by the Sturge, that is k is equal to 1 plus 3.322 log base 10 into n. N, that is number of observation present in your data set. Let us consider if n is your 100, then your formula for this one we can calculate. And so the number of classes which can be exist in your data set, or you can make the classes, that is 8. Now, once you decide how many classes we can make within your data set, now we have to decide what will be their size of the class interval. So for this, we have to use this formula, that is class interval range divided by number of classes. So we'll get how the size of this class it should be there. So you can make your frequency distribution table based on those things. So while making this class interval, there are again three types of the class interval: exclusive method of the class, inclusive method, and open-end class method. But while doing this class interval, we have to keep some points in our mind. That is, the class, it should be uniform. Whatever the your width of this class, it should be uniform. Then range, which should be cover whole your data set. Then your data set data, it should be the continuous, and it should not be overlapping to each other. This point need to be considered while making this class interval. So while talking about the exclusive methods, let us consider the data set is given about the wages, where you see the range of this one 0 to 100, and another class is 100 to 200, then 200 to 300, and the frequency for particular class, how many times it is repeated, that is frequency it is given. Now see, when you are talking about the exclusive, it means you have to exclude your upper class. So whenever your observation is 100, you not have to put into this first class, you have to enter it in your second class. That's why your upper limit of the one class, it is your lower limit of the next class. And when we are talking about the continuous data set, so that's why it is called exclusive method. Exclusive, it means we have to exclude your upper limit and it is included into your next lower limit. So it is called exclusive method of the classification or class interval. When you are talking about the inclusive, you have to means include the both limit of your class. Now see the example, the number of worker 0 to 100, 101 to 200, 201 to 300. It means it is dealing with only discrete data set. It means whenever you are talking about the first class, it means your lower limit and your upper limit both are included in the same class. It not be overlapping. So such case, we are talking about inclusive method. It means inclusive, it means it include the both upper and lower limit in the same class. But whenever we talk about the exclusive, it exclude the upper class and include in the lower class. But when we are talking about the open-end classes, it is like that the first class, that is below 100, so it means below 100 we don't know how much the class is going, but next class is 100 to 200, 200 to 300, but again the last class is 400 and above. It means there is no limit, and again there is no limit, so both end are open, so it's called open end classes. So while making this class interview, we have to take care about it. Now, measures of standard tendency. We have seen about the brief about the statistic. We're talking about the limitation of the statistic. Then we're talking about the frequency distribution. We're talking about the different classification of the data. We're talking about the different class interval, that is inclusive, exclusive, and open end. Now, what is the measures of standard tendency? See, let us consider in your class, there are 50 students and you make the average. Let us consider it is 179.3. This is the height of your student, average height of your student, or mean of your height of your student class. Then this number which represent your whole class, it means whatever the person in your present in your class or your uh, classroom, the height of the student, that is on an average, that is 179.3, and this single number which represent your whole data set. Let us consider this is your 1.79 and which represent your whole number. Let us consider is another example 15.5. It is the average of all this number and which represent your whole number, and this number is located at the central position of your data set. So when you are talking about the center tendency, it means the value which represent your whole group and is indicate or is located at the center position of our data set. This center tendency we can call it average, mean, likewise. So in center tendency, according to the scientist Bole, it's defined as statistical constant which enable us to comprehend in a single effort the significance of the whole. It means single value which represent your whole population, which represent your whole data set. So it is called average or mean. So this center tendency or this average, it is further classified into two broad categories, that is mathematical average and positional average. In mathematical average, we are seeing the mean, and this mean, that is arithmetic mean, geometric mean, and harmonic mean. But in positional averages, we are talking about median and mode. This median and mode, it is not calculated based on the any formula. It is the position which is available, position which made by the number within the your data series. That's why it is called positional averages. So we see there are different formulas we need to be keep in mind while doing the calculation of the arithmetic mean. So the first formula, it is very basic formula about arithmetic mean, that is x bar, which is represented by the arithmetic mean or averages, which is represented with x bar. That is total number of the all observation uh, divided by the total number of the observation. Sum of the all observation divided by total number of the observation. Okay, so this is your first formula, but this is, we can call it ungrouped data. Ungrouped data, it means we not have the classified data. When you're talking about the classified data or group data, the formula it become modified. We have to make the frequency of this particular class. We have to make the multiplication to the number, and we'll get the formula, that is summation of the fi xi divided by total number of observation, that is summation of fi. Summation of fi, it is nothing but your total number of the observation present in your data set. So this is basic formula for the arithmetic mean. When you are calculating arithmetic mean, 4-digit number, 5-digit number, so it is very difficult to handle. So such cases we can use this deviation method for the calculation of the arithmetic mean, where we have to make this a, that is arbitrary constant, which is present, or you can choose any number which is generally located in the centralized position. So we can make as the arbitrary constant, and we have to make the deviation from the each number. With taking this arbitrary constant, we get di. So this formula it become modified, and it called deviation method for calculation of the arithmetic mean. It is again for the ungrouped data set. And when we are talking about the group data set, again, we have to make the multiplication with the frequencies. That is the only difference between this group data and ungrouped data. Another formula about the weighted mean or average, it is about the weight which is assigned to the your numbers. And then we have to make the summation of the all this weighted observation divided by the total number of the weights. So we get the weighted average of the observation or your data set. Now, while talking about this arithmetic mean, or you have seen the different formulas, there are some properties of arithmetic mean. The first property about arithmetic mean, that is algebraic sum of the all deviation of the set of values from their arithmetic mean, it is always 0. So symbolically, we can write it summation of all your values, that is xi minus x bar. It means when you deduct or when you minus your arithmetic mean from each of the observation, then your value, it is always 0. That is your first property of the arithmetic mean. Let us consider the data set is given, that is xi, the 2, 4, 7, and 8. Whatever the average we are getting, that is x bar, it is the average. Let us consider when you are talking about the xi minus x bar, 2 minus x bar, 4 minus x bar, and so on. So whatever you are making the summation, it is always 0. So this is your first property. Next property of arithmetic mean, when you square of the deviation, we make the square of the deviation about the xi minus any arbitrary constant or x bar minus x bar is always minimum. This value is always minimum. When you take the square of the deviation from their arithmetic mean, always minimum. It means when you take any arbitrary constant, let us consider xi minus a, whatever the value we are getting, it is always greater than summation of xi minus x bar. Okay, this is a concept about your second property. The next property about the adding and subtraction of the any constant of the each observation, your series will add or subtract the same constant to the arithmetic mean. It means let us consider your series mean is x bar. Let us consider there is a series x1, x2 up to xn, and you make the average of this series is x bar. But when you make the addition of any arbitrary constant, let us consider a, then x2 plus a, and so on, xn plus a. It means you make the addition of any constant to the each number of your series, then your new arithmetic mean, it become a, right? This is, you have to just addition. Similarly, when you're making the some subtraction instead of the addition, then new mean, it become x bar minus a, likewise. Similarly, when you are talking about the multiplying or dividing any constant to the each number of the series, the new arithmetic mean, it is also same by multiplying or dividing the same constant. So it become x bar divided by a or x bar multiplied by a. This is your new arithmetic mean. This is your new arithmetic mean. Okay. So this is the properties of arithmetic mean. In the examination, so such kind of the tricky question will arise. Let us consider the series of the, let us consider question, it become the series of the your data set. The arithmetic mean is given x bar is equal to 20. If you make the addition of the any constant, that is a is equal to 5, then what will be the your new arithmetic mean? The new arithmetic mean is equal to 20 plus 5, that is 20. Understand? So such kind of the question will arise in your examination. Another thing you have to take under consideration, the some relationship between the different your arithmetic mean, that is geometric mean. When you are talking about geometric mean, it is a uh, square root of multiplication of the arithmetic mean and harmonic mean. Okay, so this the relationship you have to take under consideration. Then another thing, your harmonic mean always less than equal to geometric mean. It is always less than equal to arithmetic mean. Another thing, that is mode, it is always equal to 3 times of your median minus 2 times of the mean. So this relationship also keep in mind while in examination point of view, and based on this some question will be raised. Now this is, we are talking about now positional averages, that is median and mode. When you are talking about the median, it means let us consider the series is given to you, and when we arrange it in ascending or descending order, the central value which is indicate the median of those series. Okay, and this median value which divide your whole group into two equal parts. Let us consider there are the total 13 observation. So the middle value, so first all the this 13 observation we have to arrange in ascending or descending order. We have to arrange it ascending or descending order. And once you make the arrangement of ascending or descending order, then we have to make this formula, that is 13 plus 1 divided by 2. So seventh number of your series is called median. Seventh number of your series is called median. So similarly, when you are talking, this is formula for the ungrouped data, the series is given this. But when you are talking about the group data or classes is given, like class is given 10 to 20, 20 to 30, and the particular data set is given to you, then in such case, you have to use this formula, median is equal to L plus n by 2 minus m whole divided by frequency into C. Where your L, it is called your lower limit of your median class. Then what is median class? Median class, it can be get by whatever the numbers we are given. Let us consider the n is equal to 100, then n divided by 2, that is 50. So we have to make first cumulative frequency of our data set, and in the cumulative frequency, if your number which exceed 50 and 50 then more than 50, this corresponding class we can call median class. So this is n by 2, and m, it is called the cumulative frequency of whatever you are calculated of the this preceding class of your median class. Then frequency f, it is the frequency of your median class, and c is a class interval for this particular median class. Okay, this is the formula for the calculating the median. Now mode, it means which number or which value which is most frequently repeated. Let us consider you have the given the data set x1, x2 up to xn, and out of this x7 is repeated 14 times, that is maximum time. So this number which indicates the mode of the your series. This is about for the ungrouped data, but when we are talking about the group data or classified data, we have to use the formula mode is equal to L plus F0 minus F1 divided by twice F0 minus F1 minus F2 into C, where the L is your lower class of your model class. The model class, it means in your frequency data set, which number or which class is repeated number of time, more number of time, this corresponding class, it is called model class. And this model class, we have to choose the value f0, that is the frequency of your model class, f1, that is the frequency of preceding of the model class, f2, that is frequency of the your succeeding model class, and c is your class interval. So likewise, this is the formula for mode. So once you're talking about the median and mode, next term is about the quartile. Quartile, it means whatever we're talking about the median, it means we divide our whole series into two equal parts. But when you are talking about the quartile, we divide our series into 3 points, that is lower quartile, median, or upper quartile. It means we make the 4 groups of our series. Let us consider this is our series. When you make it in 2 parts, that is your median. But when you make it into these 3 points, 1, 2, 3, and 4, it's called quartile 1, quartile 2, quartile 3, and quartile 4. Okay, so this is called quartile. So this formula, when you are talking about the ungrouped data, we already seen in a median, that is n plus 1 divided by 2. That is your median class. But when you are talking about the quarter 1, so whatever our median class formula, we have to make it divide with the 1 by 4. So we make the 1 by 4 into n plus 1, that is atom, we're talking about the first quartile. And when you're talking about third quartile, it becomes 3 by 4. And when we are talking about the quartile 2, that means 2 by 4, it means 1 by 2. And same formula, we are talking about this median. So quartile 2, it is nothing but your median. So keep in mind. So this is a quartile about the quartile. But when you are talking about the group data set, the formula is same as of your median for the group data set, but the change about this one, that is, you have to multiply which quartile you are going to be make the formula. Let us consider I have to calculate the first quartile. So my formula, it become L plus n by 4 minus m divided by into C. That is for the first quartile. But when you are talking about the third quartile, then it become 3 by 4 divided by 4 into the formula is same, just to the multiplication factor of this one, it changes. So it is about first quartile, second quartile, and third quartile. Now percentile, most of the students are get confused about this percentile value. This percentile and percentage, both are the different things. When you are talking about the number of persons or number of mass obtained out of this number, so let us consider we are getting the n number out of capital N into 100. It is called percentage. It is called percentage. But let us consider you are getting the 18 percentile. You are getting the 80 percentile. It means out of this you are getting 80 percentile. It means almost 80% of your data set or 80% of the students who are getting 80% or below 80%. It means 20% of the students which are giving the more than 80 and more than 80 number of the percentage than you. So when you getting the 80 percentile, it means there are 20% of the students uh, uh, which are above, next to you. Okay, so this is about the percentile. The formula for this percentile is like the median formula, but we have to make it whole your series into, let us consider in quartile we are making the only 4 parts, but in percentile we have to whole series we have to divide it into 100 parts. So this formula it become I into this, I is multiplied with the your what percentile you are getting. If you want to 25 percentile, then formula it become 25 divided by 100 into n minus n. This is formula. When you are getting 50 percentile, you are getting this one. So this is about the percentile. We are talking about this measures of center tendency, and we are talking about the center value which represent your whole data. Now consider the example. I would cross the river, and which having the average depth of this river is about 4 feet, and the person height is 6 feet. So when you are walking throughout the river, it means there is no chance of the you are getting or you getting down to the river, because you are already having the height is 6 feet, and the average depth of this river is 4 feet. But never cross such river where the 4 feet deep on the average. It means your average will mislead you, and you will become in trouble while crossing this river. Understand? So this concept of measures of dispersion comes into exist. It means how much your center value, how much your center value is deviate from the each number or each value is indicated by the dispersion. Dispersion is show the degree of variation by the various measures of dispersion. When you're talking about the small dispersion, it means high uniformity. If there is large dispersion, it means there is less uniformity. And how much data is spread about your different observation from the center position. This is indicating by the dispersion. In the dispersion, there are different measures. That is, first one is variance, range, standard deviation, then mean deviation, coefficient of variance. Okay, so these are the different measures which need to be considered while studying the dispersion. So we'll see the one by one. The first one is range. Range, it is nothing but the difference between highest value and the lowest value of your data set. Then when you understand the range, then next term is coefficient of range. It is calculated with the ratio of the difference between largest value and lowest value divided by the total of the largest value and smallest value. This is the formula for coefficient of the range. When you are talking about the mean deviation, it taking the absolute deviation with respect to their arithmetic mean. It is not consider the positive and negative value while doing the mean deviation, and therefore the measures of dispersion, it is another terms which is generally used in the uh, how much deviation from this center value irrespective of their sign plus or minus. So when you take the deviation from its arithmetic mean, we can take the deviation from median, you can take the deviation from the mode. So this one we can mean deviation about the mean deviation about the median, or mean deviation about the mode respectively. When you are talking about the group data set, so same formula, just we have to make the multiplication of the frequency to this deviation. So it become the formula for the group data set. Once you calculate the mean deviation, the based on this mean deviation, you can calculate the coefficient of the mean deviation is equal to value of the mean deviation divided by mean, median, or mode. At what basis we are doing the calculation of the mean deviation? Just this number we have to make the division into 100. So this we can call coefficient of the mean deviation. Now next term, that is standard deviation, it is denoted by the sigma. Carl Pearson introduced this concept, and important of this, we can understand how much is deviated from the center value, and this also called root mean square deviation, because we are taking the square root of this your data set, and when you make the square of this standard deviation, it converted to the variance. So for formula for calculating this standard deviation, it is like and it is denoted by the sigma. So sigma is equal to 1 upon n summation of xi minus x bar bracket square. So it is take care of the all the positive and negative signs deviation while making the square. So always it is the absolute value, or you are getting the value always in positive nature. So this is your standard deviation. There are different formulas. This is a standard formula. By making the simplification, we make this different formula. But when you are talking about the different high order numbers or high digit number decimal numbers, we can make the deviation method for calculation of this standard deviation. When you are talking about the sample deviation, just we have to modify this formula with n to the n minus 1, because we are dealing with the small samples, and we have to make some arrangement about the constant which need to be considered while calculating the standard deviation for the sample data. Now, once you calculate your data set for the standard deviation, and when you need to be combined or pool this standard deviation, we make some formula, we make some use the formula that is x double bar. It means pool of your averages, that is number of observation while calculating the x bar 1, number of observation while calculating the x bar 2. So this is, you have to make the multiplication of this number of observation as a weight and divide by total number of the observation n1 and n2. You will get the pool mean, and this pool mean, it can be used in the next your calculation. Now, while combining this standard deviation of the first series and second series, the formula it become n1 into sigma 1 square. N1, that is first series total number of observation. Sigma 1, that is your variance of the first variance of your first variable. N2, that is total number of observation in second variable. Sigma 2 square, that is variance of the second variable. D1, that is your difference between the x bar minus your full difference. D2 square, that is the this one, and you have to make the square of this bracket. Okay, so we'll get this all the value we have to put just into the formula. We'll get the combined standard deviation. Now, next important term generally used in coefficient of variance. This coefficient of variance, we are getting the ratio of standard deviation and mean into 100. So this is unitless measure, coefficient of variance. And when you are using this, generally this standard deviation, we are using how much deviation or how much variability within your data set we can understand. The CV also act like this, but while talking about the CV, let us consider there are data set of the plant height and the data set of the number of grains. While talking about these different units simultaneously, and we have to make some kind of the comparison, then CV is fruitful, or CV taken under consideration while comparing the variability within your data set. Now variance, just to make the square of your standard deviation, we will get the variance. Same formula, just we have to remove the square root sign from the formula, we will getting the variance value. There are some properties we need to be considered while studying the variance. The first property, let us consider the Vx, that is represent the variance for the X series, and Vy, that is variance for the Y series. Then the first property, when you are talking about the Vx plus or minus Y, it is always Vx plus Vx, that is addition of the individual your variance. But when you multiply or divide each observation by the constant, then the same multiply or divide the variance by the square of this constant. It means, let us consider the x1, x2 up to xn. These are the total number of observation present in your data set, and the variance for this series, it become Vx. Okay, but next stage, what we are doing, we just multiplying the constant to the each number. We are multiplying the constant to the each number, then your new variance, it becomes the a square into your previous variance, like this. Similarly, things we have to make for the dividing also. So when you are talking about the properties of the variance, when you multiply or divide any constant to the series, then the square of this value, we have to make the multiplication with the previous one. Let us consider in the exam, let us consider the series of the variance. It is given Vx is equal to, let us consider 40, and the any constant, that is a, we are multiplying with the 2, then the new variance, it become the new variance, it become 2 square into 40. So it become 160. That is your new variance for your series. But when you are talking about the addition or subtraction of the any constant to the each number of the series, then there is no change. There is no change in the variance. It means when you add or subtract any constant, there is no change. So keep in mind while talking about the variance or its properties. And based on this, the question will arise in the examination. Now another important term, that is standard error of mean, that is SCM, generally used in the different analysis. This standard of error of mean, it is nothing but your standard deviation. But when you are talking about the only single variable, then it's called single variable, then it is called a standard deviation. But when you are taking consideration of the different sample or different standard deviation over the sampling distribution of their means, then it's referred to the average magnitude of the difference between your sample estimate and population parameter taken over the all possible sample from the population. It means when you're talking about only one variable, that is x, then it is called standard deviation. But when you're talking about the x1, x2, x3, you are considering the all things simultaneously, then the standard error, it is come into the picture, and it is take care of the all the deviation throughout your data set. The formula for calculating the standard error, that is sigma divided by square root of n. Sigma, that is standard deviation, and n is your number of observation. And when you are talking about the samples, then instead of the sigma, we replace with yes. Another thing, that is quartile deviation. We already seen in the measures of center tendency how to calculate Q1, Q2, or Q3, that is quartile. And based on this quartile, we make the deviation formula, that is quartile third minus quartile 1 divided by 2. That means we are getting the quartile deviation. And when you proceed for the coefficient of quartile deviation, it is equal to quartile 3 minus quartile 1 divided by quartile 3 plus quartile 1. This is formula for the coefficient of quartile deviation. Now we are proceed further about talking about this moments. When you're talking about the moment, it means it gives the arithmetic mean of the various power of the deviation taken from its taken from mean of this distribution. Let us consider we have seen the formula taking the deviation, that is summation of xi minus x bar. Okay, we already know the deviation, that is first property of your arithmetic mean. While you are taking the deviation from your first deviation from its arithmetic mean, it is always 0. So when you make the average of this deviation, it is always 0. So this, it's called your first moment. It is called your first moment about the mean, because we are taking the deviation from its mean. So it is called first moment about the mean. When you make the deviation from the second, that is second order, when you are talking about the second order, the power of this bracket, it become 2. When you are talking about the third moment, the power of this bracket, it become 3. When you are talking about the fourth moment, it is talking about the fourth. So it means it's called the moment about the your data, or it is taking from the your arithmetic mean. So while considering the first moment, always it is 0. The question about the exam, that is the first moment always 0. Your second moment, it is always your variance, that is formula of the variance. Then this is when you are talking about the group data, just multiplication of the frequency to this deviation, you will get the formula or get the value for the first moment, second moment, and on for the group data set. Now some of the relationship we have to keep in the mind. While we are talking about the first moment, it is always 0. And when we are talking about the second moment, that is variance, and it can be calculated with help of this relationship. Now this one, U1, U2, U3, those are the relationship between those movement when we are talking about the origin, when it passed through the 0. Then such kind of the relationship, it is exist in the movement. So this relationship, keep in mind in some point of view. So then the important topic about the skewness. When you are talking about this moment, first moment, second moment, third moment, and fourth moment, that is mu1, mu2, mu3, and mu4. And based on this, we can calculate the skewness of this data. The skewness, it means lack of your symmetry, which indicate, let us consider in the graph you've seen, this is symmetrical distribution. It means it's showing the normal distributed graph, or it is bell-shaped graph. At this case, your mean is equal to median is equal to your mode. When your value of mean, median, mode are equal, then it's called symmetrical distribution. But it is not exist, then it's called skew distribution. But at that case, you're seeing when you're talking about the mode, if your mode is greater than your median and it is greater than your mean, then it's called positive skew or left side skew. And when your mean is less than median and median is less than mode, then it's called negative skew or right side skew. So this thing keep in mind about the skewness about your data set. So this basically the skewness can be calculated based on the formula that is denoted by the beta. The beta one is equal to mu3 square divided by mu2 square. That is one means third moment about your mean, or it is second moment about your mean. You have to make the this data set, or you can calculate this value of beta, and based on this beta we can interpret your results. If your beta value is equal to 0, it means it is symmetrical distribution. It is less than 0 or more than 0, accordingly positive or negative skewness it is present in your data set. Now kurtosis we describe about the thickness of the curve, how much peak or how much height of this curve it is exist in your data set. It is talking about with help of the kurtosis. When you make the graph of this one and we calculate the value of this kurtosis, it is denoted by the beta 2 is equal to mu4 divided by mu2 square. Mu4, that is the fourth moment of your data set or second moment of your about the mean it is given, and when we take the ratio of those we will get the beta 2, and based on this beta 2 value when it is more than 3, that is called leptokurtic. If it is equal to 0, it's called mesokurtic, or it can be symmetrical or normal distribution, and when your beta 2 is less than 3, then it's called platykurtic. So basically three types of kurtosis. This is leptokurtic, mesokurtic, and platykurtics. So it is about the your kurtosis, and based on this value of the beta 2 we can make our interpretation about our data set. Now, once you understand all those things, I like to be incorporate for today's lecture, that is test of significance, and it can be important lecture for your important topic for your examination point of view. When you are talking about the test of significance, first of all, you have to understand what is parameter, statistic, estimator, and estimate. When you are talking about parameter, it means it gives the characteristics of the population value and is known as the parameter. When statistic, it means characteristic of the sample value. It's called statistic. Estimator, it means statistic, whatever they are estimating about the parameter is called estimator. And estimate, that is the specific numerical value of the estimator, it's called the estimate. Let us consider when you are talking about just we have studied the mean, variance. Okay. So when we talking about the population, the mean is represented with the mu. And when you are talking about the sample, it is represented with the X bar. So this formula for calculating the X bar, it's called estimator. And the value which is getting from this formula, it's called statistic. And we're talking about this population, that's called parameter. Okay. So similarly for the variance, the sigma square, it is for the population parameter, small s square, that is called sample variance. And the formula which are calculating is called estimator. And what the value you are getting, that is called estimate of this parameter. Similarly for the proportion things. So for test of significance, these things we need to be understand first. While testing the significance, we have to first formulate the null hypothesis. Null hypothesis, this is talking about the definite statement about your population. It means whatever the things we need to be test, we are first or initially considering everything is equal or everything is the same. So it is called null hypothesis. And if you're talking about the alternate of this or complementary to this null hypothesis, then it is called alternate hypothesis. Null hypothesis is denoted by H0 and alternate hypothesis is denoted by H1. Now, while comparing this null hypothesis and alternate hypothesis, we have to make some level of significance. The level of significance which indicate the probability or maximum probability at where we can take the risk of the type 1 error. It means where we are rejecting our null hypothesis even it is true. And this level of significance also called size of the type 1 error. Then the two terms which comes into exist, that is type 1 error and type 2 error. When you're talking about the type 1 error, it means you are rejecting your null hypothesis. When it is true, then it's called type 1 error or it's called false positive. and it is denoted by the alpha. And when you accept your null hypothesis, when it is false, then it's called type 2 error, or it's called false negative, then it is called, and it is denoted by the beta. So based on our alternate hypothesis, we can make again two type, one tail, two tail. We have decided based on our alternate hypothesis. When you are talking about the mu1 is not equal to mu0, it means we have to compare the two means which are equal or non-equal. When we are considering the alternate hypothesis, is it not equal to? It means we are talking about the two tail alternative. But when you are taking only considering the only one case, that is mu1 is greater than mu0 or mu1 is less than mu0, it's called single tail. Or based on this notation, we make it right tail or left tail. Okay, so this is about our basic of the null hypothesis, level of significance, type 1 error and type 2 error. Now there are different statistical tests which are generally used for testing the hypothesis. There are parametric and non-parametric tests. The parametric tests generally assume the normal distribution, and non-parametric tests not consider any distribution, or it can consider any kind of the distribution. We are assuming our variance is homogeneous, but in case of non-parametric, it may be heterogeneous or it may be homogeneous. We are using the data set that is a ratio scale or interval scale, but in non-parametric, we are dealing with the ordinal or numerical data set. When we are talking about the parametric, we are considering the relationship with the different variables that is independent to each other, but non-parametric, maybe whatever things. But when we are dealing with the parametric, we are talking about the mean. But when you are talking about the parametric, we are talking about the median. So there are different tests we are considering, that is J test, T test, F test. Those are comes under the parametric. But when you are talking about the non-parametric, the chi-square, sign test, Wilcoxon, sign rank test, run test, Mann-Whitney, Kushkel-Wallis, or Friedman, those are the different tests where comes under the non-parametric. There are different tests which are exist based on your data set, what kind of the data set you are dealing with. It is binary data, continuous data, it is categorical data or non-categorical data. So based on this different tests or different ANOVA, different tests, it is we can consider while doing the testing of the significance. So we are just brief about this tests which are generally used in the testing of hypothesis. When you are talking about the last sample, we are using the Z test. Again, this Z test, we are talking about the one sample Z test or two sample Z test. In the Z distribution, the range of this distribution is minus infinity to plus infinity, and the different formulas we are need to be considered while talking about this test. Keep in mind, while talking about the Z tests, their tabular value are the fixed. That is, when you are talking about the 1%, your 210 tabulated value is 2.58, and when you are talking about the 5% level of the significance, your 210 test is 1.96, and so on. Your value we have to keep in mind. And when what you are using these formulas, what the values you are getting, the based on this value or calculated value, if it is more than your tabulated value, then your test is significant, and you are going to be reject your null hypothesis, and you can call it your significant result. But when you are dealing with the small samples, that is n minus, that is, it is less than 30 samples, then we are using the student t-test, and it is given by the W.H. Gossett. It is also called student t-test. Why we are called it is student t-test? Because at the time when he is invited to student, it is working in binary company, and that time there is no allow publish their own works there by their own name. So that's why they make the name to this test as a student t-test, because it is for their students. So range of this t-test, it is minus infinity to plus infinity. Here also one sample test or two sample tests, and another is pair t-test. When you're talking about the one sample test, we are considering this formula are taking the table value at n minus 1 degrees of freedom. When you are talking about two sample t-test, we are taking the formula and we are seeing the critical value as n1 plus n2 minus 2 degrees of freedom. Pair t-test, we are using only when the both sample are same and both samples are dependent to each other. It means we are taking the observation on the same object at different intervals. Then we are comparing this their significance with help of the pair t-test. This test statistic, that is formula, we can use for the calculating this one, and for this n minus 1 degrees of freedom will be considered for the checking the critical value from the table. F test generally used for the checking the equality of the variability between the two population. The range of this F test, it is 0 to infinity, and we have to make the hypothesis like your sigma 1 square is greater than or equal to sigma 2 square, it means variance of the first variable is equal or not equal to variance of the second variable. So we are using the F statistic, that is we have to just keep the ratio of this larger sample variance divided by the smaller sample variance, and we have to make the degrees of freedom n minus 1 and n minus 2. We have to calculate the critical values for those testing the significance of the F test, and based on those results we can make the conclusion. If your calculated value is greater than your tabulated value, then we reject your null hypothesis and your test is significant. Another thing is chi-square test. It is non-parametric. It is also called distribution free, and the range of this chi-square distribution is 0 to infinity. So there are different utilization of this chi-square. We can use this chi-square for testing the independence of attribute. We are using the testing the goodness of fit. We are using in genetic problem. Also, we can use this chi-square for the checking the homogeneity of the variances. So all these things we need to be considered. And this chi-square is generally used for the when your degrees of freedom is up to 30. But if your chi-square your data set or your degrees of freedom is exceed 30, we have to make some correction, or you have to use the Fisher approximation formula, that is Z is equal to. It means we have to shift it to the Z distribution, and we have to again compare with the tabulatory value of the Z test statistic based on this chi-square value. Those are the formula for calculating this population variance, then goodness of fit, and independence of the attributes. For non-parametric tests, there are different tests. Just I listed out all those tests because of just we are overlooking all those. When you are talking about the one sample non-parametric test, we are using the sign test, Wilkinson sign test, run test, Kolmogorov Simron goodness of fit. When we are talking about the two sample tests, there are pair T test, Wilkinson match pair sign test, Mann-Whitney test, Kolmogorov Simron test. When you are talking about the case sample T test, it means more than two samples when you are considering for the non-parametric test. At that case, we are talking about the Kruskal values and Friedman test. Generally, it is called the analysis of variance. But when you are talking about the analysis of frequency, we are using this chi-square test for the categorical data, and just we are seeing the goodness of fit and independence of attribute. So this is about the parametric and non-parametric test. Thank you very much. Hello.
Thank you so much, sir. This is very nice presentation, sir. And
I,
hello,
I like
sir.
to
Am I audible, sir?
yes, you are audible.
Yeah. Okay, sir.
I like to take some question from the students also. Hello. Is there any question?
Yes, sir. Regarding this,
Yeah. Okay.
what
Okay.
type
Yeah.
of
Sir.
Yes.
what type of multiple choice question will be asked on this topic, sir? On
See,
parametric, non-parametric.
actually, see, sir, whatever the topic which is given to me, and it is very basic about the statistic. And when I'm talking about the economic group, the part of this statistic not about this basic, but it is some advanced thing also incorporate. If you are talking about the econometrics, it is a see the first of all the economics. It is a sister or sister subject of statistic. The most of the things is considered while studying the statistic. Such kind of things, when you are talking or studying this statistic, you have to first understand the basic things. And what we are deliver lecture today, so such kind of the question may arise like when you are just we are explaining about the properties of the arithmetic mean or properties of the variance. So based on this, the question may arise. Suppose the series of the series is given to you, or series of the series directly mean is given to you, and ask what will be the then new arithmetic mean. If you deduct some numbers from your series, then what will be the your next new mean, and the option will be given to you. So my suggestion to all the listeners, you must refer the BL Agrawal or program statistics for the MCQ or preparation of the subject of the statistic or basic statistic. You must refer the program statistic which is given by the BL Agrawal.
Thank you. Thank you so much, sir.
Okay. Is there anything? I like to Is there any question from anyone regarding today's topic? Hello.
Yeah, I think no one has any query, sir.
Okay then. So we stop here. Otherwise, you can
Yeah,
conclude
yeah,
this session.
okay, sir. Oh, thank you so much, sir, for this session. Definitely, sir, this session will help to our participants for their respective examination. Thank you so much. And I would like to thank for all the participants also their active participation and patience to listen these sessions. Thank you, all of you. Thank you. Have a nice day, sir. Thank you. I concluded that
Thank you.
this session is over.